set? Okay, great. Wasn't sure if there's an intro. Thank you for being here. Thanks for having me. Thanks to the volunteers and the audio-video team. By way of introduction, my name is Connell, and the topic for my presentation is building a predictive pipeline to rapidly detect phishing domains. Now, this is some work that I had done in the November, December time period. I'm going to publish my slides, and I've also pushed all of my source code to GitHub, and I'll be doing a live demo during my presentation as well. A little bit about myself. I am the security analytics lead at PatternX. So we are a security startup based out in Silicon Valley. And before that, I was at Northrop Grumman. Fortunately for me, I was in a role that was doing a lot of security research, so a lot of predictive modeling, a lot of cyber attacks and things like that. And that's, for me, I've always been a security guru. And I was fortunate to sit next to data scientists and things of that nature. So for me, there's been a lot of dialogue about data science and artificial intelligence. And for me, everything I've learned has been on the job. So I don't have a master's, I don't have a PhD, but I do have a ton of domain experience, and I've always been very interested in statistics. And so that's kind of my background. Here's what the agenda looks like. So I'll start off with a little bit of a primer, some of the ingredients that go into the work that I had done, and also the elements of where I'm applying this work. So the first of which is the Certificate Transparency Log Network. I'll get into some of the phishing. I think there's a lot of, in this crowd, it's universally understood whether it's malicious downloads or credential theft. And then some of the ingredients, again, that make up supervised machine learning. I'll go into the implementation, some of the training data, the features, feature engineering, extraction, and the accuracy that I'm using to determine if, the suitability of my project. And at the end, again, we'll circle back with the command line tool and this IPython notebook that I built. And it's a 50-minute time slot, so I've got a lot of flexibility and should have plenty of time for Q&A, and I'll interject as I go along. So with that, for my audience awareness, how many of you are familiar with the Certificate Transparency Log Network? Okay, great. A couple hands. And how many of you have ever trained a predictive model? Okay, more hands than I was expecting. This is great. So the Certificate Transparency Log Network is all about open auditing and monitoring for the issuance of SSL certificates. And you might notice, what on earth does this, could this possibly have to do with Twitter? There's the Twitter check mark. And I thought that was a good analogy. So I don't work at Twitter, but I would imagine that, for validating identities, let's say if you were to look for Mark Wahlberg, you would search for it on Twitter, and there might be 30 or 40 accounts. And your visual cue for which one is actually him is the account that has the check mark. And I imagine that if instead at Twitter of having, they being the sole authority, they had outsourced that to 170 different authorities and said, we're not going to do any monitoring, no auditing. They will individually, use their different barriers and metrics for validating identities. That would sound a little bit crazy. But that's exactly what we have with SSL certificates today. So when you buy a domain name and you want to prove that, hey, I own this, I want to get an SSL certificate, they use those certificates to validate, who that is. And there's no way, you've got lots of different attacks, whether it's issuing subordinate certificates or a certificate authority gets popped. You have the issuance of these certificates, and again, there's no monitoring. So that's what this is all about. It was a project that started in 2013, and for the work that I've done, it's the data input. So every time an authority issues an SSL certificate, it also gets logged. And when I have that certificate, specifically, I can see the common name that it's being issued to, the domain name. And I'm looking for heuristics and things that look like phishing. So this is pretty much as soon as they go operational. There's a Python library called CertStream, and there's a security team based in Silicon Valley that was nice enough to write this, and this is available on GitHub. It is you have this log network. For me, I really like doing prototyping in Python. So this is a Python-based utility. You import it and you can just run it. I'll show you what it looks like as well. And you get this fire hose of domain names that you'll see on the right-hand side. And then for the problem space, we're looking at phishing. And if that's not exponential, I don't know what is. But this is the adoption of phishing attacks being conducted via HTTPS. And when you look historically, especially the last 3 or 5 years on different attacks, you've got exploit kits, which they're still around, they're still present, but the sophistication for them can be pretty high. Versus phishing, you think you can get a domain name for free. For now, you can get an SSL certificate from some of these authorities for free, and you can get hosting for free. So it's very cheap, and in most security programs, I think most of us would agree that humans are the weakest element. So that's, I think, why you're seeing this popularity. This is a diagram from a group called Phish Labs, and again, you can see every quarter there's a lot more phishing attacks being conducted via HTTPS. And this is also what inspired me to build this project. So for me, I'm more in the predictive analytics and then the security space. And this was a really popular prototype from an anonymous researcher named Xors. And he was looking for suspicious phishing keywords. He had a couple different characteristics that I used and borrowed in the work that I had done. And you'll see at the bottom, he's got predetermined scores and weights for the different criteria. And I thought, when you run it, it works great. This isn't a comparative thing, but I just thought, if he had published this and he didn't have the scores, how do I know if that's the most optimal? And how do I know if he didn't miss any keywords? Or, over time, this is very static. Maybe 6 months from now, there's something, another, thing like blockchain or some of those exchanges that are not being included. So how do I know if that's representative? And again, from my background, I do a lot of supervised machine learning, and those are the questions I had asked. So looking if this is the most optimal scoring framework, if these are good keywords. And then a really important characteristic that I'll get into is a Levenshtein distance, where this is really good for me, and it characterizes string similarity. So I'll get into that in more detail. As far as building a predictive model, an important characteristic is that you have historical training data. And that I have. We've seen phishing attacks. There are tons of phishing domains. And then secondly, can we characterize what I look at when I say that's phishing or that's not phishing in the form of features? And specifically, can I do this with Python code? And the answer is yes. So I'm going to go into what that looks like in just a moment, but we're going to do a live demonstration. So this is the command line utility I've built. And you're not doing real software development if you don't have awesome ASCII art. So that's there. And I'm going to go ahead and let that run. So this periodically will hopefully see domains pop up that look like phishing. And again, I'll circle back on this in just a few moments. A little background on supervised machine learning, so what this looks like. We're going to start in the top left, the training, text, documents, and images. And the training data for this work is these host names, these fully qualified domain names. api.support.microsoft.com, for example, versus that third one, home.pavpalcountry.somerandomdomain.com. So I've got libraries that have labels of these 5,000 domains are benign, these 5,000 are phishing. And again, those labels are directly beneath that, and 0 would represent benign, and 1 represents phishing. And then just adjacent to that, you've got feature vectors, and that's just a fancy word it's about characteristics, how you describe the data. So, and the feature vectors with those labels is what gets past that algorithm. It's not like you just throw a bunch of domain names into this black hole and all the vendors say it's magic, it's a unicorn. It's just how we describe them. And what that looks like is right here. So for these aren't exactly representative, but each record here would be a domain from my training set. And the columns, those are individual features from my feature vector. And it kind of encapsulates how I describe them. And you'll see 2 of those are 0. The labels that would be benign, and 1 is phishing. And what the algorithm is doing is looking at the differentiating characteristics between those two classes. And when you think back about the keyword-based, rule-based tool, it's going to determine the appropriate weights based on my training data, which for me is huge. Because then I can iterate very quickly as the training data evolves, or if I have to update my features, if there are things that I should be looking at that would distinguish these two classes that I'm not. And then I don't have to go adjust every single feature. And then at the bottom, after I train the model, the data input, this is that search stream framework. Those are all of the hosts, the fully qualified domain names from the Certificate Transparency Log Network. And as they come in, I'm extracting those characteristics that I had from training, scoring it with my predictive model, and then I'm saying this is either phishing or it's not phishing. Any questions on that? Okay. So I've broadly, kind of defined the machine learning lifecycle depending on the problem that you're solving. This can vary, but for the work that I've done and doing supervised machine learning where I have the labels, I know what the data is, this is a rough idea of what my process looked like. So starting in the top right, we have this idea. I think I can build a predictive model that encapsulates how I identify phishing domains. I'm going to normalize the data. So again, for me, it's that search stream framework. That helps a lot. But maybe if you're deploying this in production, you're looking at URLs, you're looking at domain names. It's really important that you're very consistent with that. And then moving on to feature exploration, I'm extracting features, I'm engineering, I'm looking at combinations of them. I might be doing some down selection. You select the algorithm, and then different algorithms have different parameters. And that's kind of that feature exploration part. And then you deploy, and again, what's really important here is there can be lots of oversights, and it's important to iterate quickly. So for example, two of the features I looked at were the keyword of account and another one being service. And for the first week that I deployed this, every accounting service, being tax season, I flagged as being phishing. And then I just added that as a feature, provided some examples of it, and then it learned that that's not a phishing domain. As far as the data acquisition, what I had done was I just took a rough list of words to use as a regex against the search stream feed to say, rough idea of kind of what I'm looking for. And I let that run for about 2 months. And again, it's all uncharacterized. There are lots of what I would say are false positives, but it's close to the criteria that I'm trying to catch. And I got some of those keywords from the popular prototype from XORs. I also looked at, there's a security researcher, Swift on Security, and he's published a bunch of exchange rules, and I took some of those words to help me use for that. Another one is PhishTank. So this is a pretty popular phishing resource that's got URLs and domains and targeted brands, which I'll get into. That was important. And then I looked at the top Alexa domains. So those are the top, the most popular million domains. And just because they're popular doesn't mean they're not malicious, but generally with phishing, the sites are brand new and they won't be in that list. And then again, model correction from the different iterations that I had done. For the keywords, I just split, from everything I'd flagged, I split it by the special characters. So it's difficult to see on the monitor, but in Python you can import the regex library and do a split on /w. And then I just get this really long word list. And I didn't take out the top level domains, but you'll see a few like account, Apple, Apple ID, support, PayPal. And I just eyeballed about 100 of these and used those as keywords. Next was popular brands that were frequently targeted. And this is the PhishTank website. You can search by targeted brand, which again was really helpful for me. So there are a bunch that I didn't think about, and there are plenty of banks. I naturally thought JP Morgan or HSBC or Bank of America. But you'll see a few more on that list. Fifth Third Bank, this First Federal Bank of California, and several others. I also added a few different email providers. And then I searched those to help seed my training data. And I found examples of both, from the data that I had started with. This one's really important, the Levenstein distances from phishing words. And what this does is it measures similarity between two strings. So I would say, give me things that have a distance of 1 from PayPal or from Apple ID, and you'll see those in the top right. And this is something that I think is very simple but very impactful, because I don't know every combination of when somebody creates a domain name and tries to make it look like PayPal or Apple ID, what it's going to be, and that's what signatures are really good at. But what I can just say is, take all those fully qualified domain names, split by the special characters, and see if it has a distance of 1 to these 30 different brands I targeted. And you can see PlayPal, ParPal, PayPal with 2 A's. That's pretty important for me. Same thing with Apple. For the targeted brands, again, this is crucial. So there are lots of brands that I was looking for, and there's a huge delineation between the presence of where that brand is. So if it's in the second level domain, like we have on the left-hand side, that's Microsoft.com, and those are all domains that I had flagged. I wouldn't say that they're malicious. I mean, it's not, one of the attacks is subdomain hijacking, so that's certainly possible, but in general, those are a bunch of domains that have Microsoft, but what it's saying is those are hosts at Microsoft.com. Versus on the right-hand side, the phishing data, I've got the brand in a subdomain, which says that that's a host on some other domain. And you can see some of those, like a couple down, apple.com.updateyourinfo-secure.gq. So apple.com, when you look at it in your browser, it would probably throw off plenty of non-technical folks, but it's actually a host on another domain. And the thing that's great is just a couple lines of Python, I can implement the logic to look for this. A few other features, I looked at the TLDs, the top-level domains, and used them as categorical features. Some of the ones have pretty bad reputations, like TK and ML, and part of that being that they're free. I looked at the number of dashes, number of periods, and the domain entropy, which is kind of a measure of randomness. As far as the algorithm, I use logistic regression, and some would argue that this is really just advanced statistics, but for me it's very fast to train, very fast to predict. It's good with lots of features, and I particularly like it because this diagram at the bottom. So some of the, it's a lot more popular to say I did deep learning and trained a neural net, but that's, for me, very unnecessary. It requires a lot more training data. The complexity of tuning the different parameters is also very difficult. Whereas this, again, is about as simple as it gets. And what it's doing is it's assigning for each feature, you'll see W of 0, W of 1, for each one, it's calculating the feature weight and the offset, which is something specific to logistic regression. And we'll determine that classification. And what the bottom is showing is that those are the keywords or characteristics that are most indicative of that class. So the positive class for me is phishing, and you'll see the histogram, the ones with the largest columns in blue. Some of those are Bank of America in the brand subdomain, or PayPal has a Levenstein distance of 1. The login keyword, iCloud keyword, things like that. On the opposite side, you'll see like the TLD is com. You've got accounting service as a keyword. You've got PayPal in the domain. It's the second level domain. So those are the characteristics that, based on my training data, the algorithm assigned those scores for. And again, this is exactly what I'm trying to get, because when I saw that rule-based utility, I was like, how do I know that PayPal should be weighted at 85 versus 60, things like that. Now, this is also indicative of my training data, and it's very important that when you build predictive models, your training data is representative of global environments. So just because I have the highest score for Bank of America in the subdomain doesn't mean that that's actually the truth if the data I trained on is not representative of everything globally. It might just be that in my training data I have all of them, but that's another thing that's really important to take into account when you're training predictive models. For measuring performance, I'll get into this in just a moment. I've got a Jupyter notebook that has all of these metrics. I got the area under the curve, the precision, the recall very, very high. But ultimately, when I was doing the deployments, I had some false positives. So in the Jupyter notebook, the metrics are a little bit lower. It's not quite 4 nines. It's probably around 99.2. And 2 of these metrics, for example, for precision, it's when the classifier cries wolf, how often is there actually a wolf? And that's another big thing with predictive modeling, the authenticity and the integrity of when it says something's on fire, is it actually on fire? Conversely, you've got the recall rate, which says out of all of the phishing domains that exist, how many am I catching? So you've got, depending on different thresholds when you train your predictive model, they can perform differently or be noisy but catch everything, and different enterprises have different risk appetites, so that's something that I'll show you as well. So we'll pivot back to the command line, and it looks like we've got a few good ones. You'll see paypal.ga up top. It's in red. You can't really see that, but let's see. Facebook customer support.tech.blog. That's probably not legit. Yeah. appleid.apple.com.security-subscriptions.ml. But you'd be surprised, I mean, especially you've got attacks that do URL padding. I don't have any right here, but it might be like apple.com and then it will have like 10 dashes, and on your mobile phone, it'll look, you don't really see the end of the dashes, they just let it go, and it looks like apple.com or facebook.com or offerup.com. But I mean, here's some examples that I think universally we can agree that those are not legitimate, and I didn't use, I used some keywords, but there are plenty of different characteristics that I use to encapsulate how I identify those, and it's flagged them for me. Again, there's a lot here, so that's good. And to give you some perspective of how noisy this is, I'm probably getting one hit every 10 seconds or so. And the certificate, the search stream library, it takes about 10 or 15 seconds to fire up, but I've seen it go usually around 200 domains per second, and as high as maybe 4,000 or 5,000 per second. So that's kind of what it's looking at. This, again, it takes about 20 seconds to really get going, but it's looking at that using my predictive model that encapsulates my intuition, what I think looks like phishing, and it's detecting those domains. It's getting a little bit faster there, you'll see. So again, this is a really simple application that I built, but that doesn't mean it's not impactful. So on the theme of doing demos, I'll show you, here's what it looks like. There's a Jupyter notebook that comes with it. And one of the things that also inspired me to do this is I've attended plenty of really high quality talks on predictive modeling and machine learning and AI. And then as soon as I walk away, I'm thinking okay, how do I get started? I've never done a lot of that stuff. I don't have all the resources, or it's not blatantly clear, or maybe I'm really curious on how they work, but all of that's been abstracted away. It doesn't matter if you're a software developer, a SOC analyst, if you know what a virtual private server is and you can spin one up in DigitalOcean or AWS and run a bash script, it'll build everything for you. And this notebook is one of those utilities, and it's kind of like going from scratch all the way to training a predictive model. So we can walk through some of this. Kind of describes what I'm doing in this notebook. I've already seeded it with all of my training data, so phishing domains and those benign domains, and kind of describing some of where I got them. The code that I use to run this, and all you have to do is press Shift-Enter, and then it'll load that into some lists. Here's how I define and compute my features, and I go into some. For this is very simple. I'm building a predictive model using spatial features. At PatternX, we've got predictive models that look at temporal features, that look at entities over a different time, and we look at different data sources as well. So again, this is pretty straightforward, and then I get into a little bit of the discussion about the features that I had extracted. And again, I've reviewed most of these. Again, here's all the code to do that. You just press Shift-Enter. A little bit more dialogue on the computing the features and how that works and what it does. So an example here is, I've got 3 different domains: ESPN.com, TorProject.com, and the top level domain is com, org, tk. And when you're looking at categorical features, what it's doing is it's creating a category for each unique top-level domain. So for ESPN.com, TLD.com being the feature, it would be 1, and everything else it would be zeros. And then for each respective domain, that's what it's doing. So then you compute those. Here's where I'm training the classifier. So I'm assigning the labels, and I've already extracted those features. So the features have a label, and I just hand it to the algorithm. And here is the one line, if you're concerned that logistic regression is not really machine learning, you could just put random forests, or you could put something else. And that's where it's training the classifier, and or the silver bullet or black magic, whatever you like. Now in production, when I'm actually training predictive models, and see the note right there, generally you'd want to do some kind of grid search. You want to evaluate, and this is so common that it's built into scikit-learn. You might want to look at multiple algorithms. You might want to look at multiple parameters for each algorithm. You might have different ways that you extract features, and you want to run all of them in parallel. You can do that as well, but for this project it's out of scope, and it's because I had done that, and I think this is such a simple and easy problem for what I had built that it doesn't really matter which algorithm I was using, I was getting the same performance. And then again, here are a lot of the classifier metrics. I'd mentioned precision and recall. There's plenty of different metrics that you can use. Again, here I've updated this a little bit, and you'll see the weights have changed based on my training data. I found a lot more examples of Dropbox, eBay, Yahoo. So those now have very high weights. And then on the other side, you'll see the top level domain being com, having PayPal in the brand domain, which when I originally got my the training data that I started with, there were over 700 domains from PayPal that were very long, but they were legitimate. And I had incorrectly flagged them as being phishing. But once I then extend my training data to include them with a label of this is not phishing, the algorithm learns how to distinguish those domains from actual phishing based on those features. Here's the precision and recall again, and I kind of what this is doing is based on different thresholds. So this is the output of my classifier as a score between 0 and 1. So the default malicious threshold is 50%. If you were to increase that to 60 or 70 or 80, your precision would go up, but the recall might go down. So I'd have more certainty on the ones I'm flagging are actually phishing, but I might miss a few in that gray area. And based again on your risk appetite, or if you're doing tuning or throttling of any predictive models that you're running, this is an important piece to look at. A couple more, the true positive and false positive rate. This is very similar to the above chart, but this kind of gives you a rough idea of how noisy it might be or how effective it is. And again, these numbers, I didn't really get into this, but when you have your 10,000 domains, when you've got your training data, what you want to do is split that into the data that you train on and then the data that you evaluate. It's usually an 80-20 split. So I would take 800 domains to train, and then I've got 200 that I test against, and I know the label, so I know if my model is accurate when it makes its predictions. This one's among the easiest to understand, the classification report. There's also a confusion matrix here. This is the one I wanted to get at. What this is showing is when the true label is not phishing, how frequently it says it's correctly not phishing. In the top right, you've got false positives where it's not, or sorry, those are false negatives in the top right when it's not phishing, and then the predicted label is phishing. Those are actually false positives. The bottom left is false negatives, where it's actually phishing, but you're saying that it's not. And that's another metric that you can use to gauge the effectiveness. And here I've got some new data. Again, I'll show you some of this in the command line tool, but you can train your model right here. You can plug in whichever ones you want and then run them, and you get the scores right there. So you'll see I didn't flag PayPal.com or Apple.com, but I did flag PayPal or PavPalVerify.com, support Apple.xyz, things like that. And I've got a few examples of what I've caught. We saw those domains that I had flagged during the demo. If I'm a SOC analyst, or maybe I kind of extend my classifier to only look at my company's brand, you would then, rather than just looking at the domain name, do some kind of more dynamic analysis. Either look at it in a sandbox, look at passive DNS, look at the whois registration. So I've got a few things here. I used a Honey client in the top, which is just, it's a emulated browser that I can use from the command line. And when I tried to hit it, I think it was my user agent that said the server would then return a 403 forbidden error. And when I looked on VirusTotal, you can't see the detections here, but there were no hits. And then when I visited in a sandbox, you can see that's the SSL certificate, and behind that is the fake PayPal login screen. Another thing that I found quite a bit of are these phishing kits. So when I would visit the page, it's it's still not fully operational. So I can just visit it, I get this directory listing, and I find these zip files. And I took a couple of them and submitted them to VirusTotal. And you can see this one is flagged as a web shell. It could be because it's just so new and it hasn't really gone live yet, or maybe there's a specific resource on this domain that they're using to run the phishing attack. But nonetheless, I've got over 100 that I've collected, and it's pretty interesting. And some of the work that I'm doing after this, again, I've open sourced this. You can use this to the extent that you'd like. But this was more about showing some of the plumbing of and the different independent variables that go into training a predictive model. For me, as actually solving the phishing problem, I would want to do a little bit more orchestration with when I flag something that looks like phishing, go fetch the domain name or go fetch the A record from that domain. See if it's shared hosting or dedicated hosting. Maybe look at passive DNS to see some of those things. Maybe look at VirusTotal. Maybe you've got a threat feed of your own if you have a sandbox, and to do as close as I can to self-adjudication of new phishing domains. Again, this is not a unicorn. It's not magic. It's not a silver bullet. And with that, I recognize for this problem, for this approach and this predictive model, there are plenty of flaws. So number one is with international characters. So if you've got Punycode encoding, mine's looking for UTF-8, but some of the international characters, they show up as XN dash. So that could probably throw off my classifier. And there are plenty of examples of phishing attacks that use Punycode, which it's with the special characters or international characters, it would be like a little L, but it would look just like PayPal.com. My classifier is not really optimized for that, but you could extend it to try to do that. Secondly, if the suspicious attributes that I'm looking at only exist in the URI, so I've got the fully qualified domain name, but the resource has my account, PayPal, whatever, the data input for me is not looking at that, but you could, again, extend this to look at URLs and have a new data input and provide it some labeled examples in your training data and do that. Third is that the search stream is only for domains that are being issued SSL certificates. If you've got attacks that only use HTTP and don't have SSL certs, I'm not going to get that data, so I'm not going to see it and I can't flag it. One of the things that I'm looking at is zone transfers from a lot of really popular top-level domains. So I can basically say from everything from, you've got com, net, org. You can go to ican.org, and I'm looking at, for example, the .review top-level domain. I can do a daily download of everything in that zone and do a diff every 24 hours, and that would show me the new domains from that day. And that would be one way to see domains that are newly registered but maybe don't have SSL certificates. Another really important one is with Let's Encrypt. It's a free SSL service. So they added wildcard certificate support last month. And I thought, the work I did is pretty interesting. I've got a ton of data. Maybe if I run it against CertStream or the log network, I'm not going to flag as much because you can hide all of, rather than having Apple ID, com, support, I forgot whatever, dot, and then your domain.com, it would just be a wildcard.domain.com. But I haven't seen any drop off in the number that I'm flagging, but that's not something that I expect to last for too long. I'm not really sure why that's the case, but that's what I'm seeing. now that I have all this training data, another option that you could do is maybe run it against if you've got the ability to do content filtering for DNS, you could run the predictive model there, and then when you're doing the DNS lookups, you would have, even if the target server is running with a wildcard certificate, you would see the full host, the fully qualified domain name, and because this runs, it's really lightweight, the data input is only a string, it's a fully qualified domain name, it's really quick. Maybe you could do some kind of blocking, maybe, there are plenty of different authorities, and I've gotten a lot of questions, like if you talk to Gmail about incorporating this or things like that, and you certainly could. And then the biggest thing here, I think, is that my recall rate is unknown. So what I mean by that is that of all of the phishing domains that are getting SSL certificates, I don't know how many I'm missing, because as you saw when I ran CertStream, there was a flood of those domain names that are 1,000 to 5,000 per second. And for me to calculate the true recall rate, I would need ground truth on every single one of those, and I don't. What I can do is, because the number of alerts and the number of flag domains I got is so manageable, I can calculate my precision rate. So when I say something is phishing, is it actually phishing? Again, it's available on GitHub. I'll leave this up for just a moment. I published this about 2 weeks ago, and I'll show you what it looks like in just a moment. It's called Streaming Phish, and the follow-on project is I've named Investigate. Get it? So I hope to have that done in time for Black Hat. I'd like to present it there. And again, this is more about, I've got lots of questions, like you could use unsupervised learning for the feature extraction. You could look at all these different data elements. You could look at the A records to see hosts that are frequently hosting phishing domains. You could certainly do that. This is more of a, when you, especially if you were at RSA last week, and for me, the last 5 years working with security vendors that are doing predictive modeling, there's a lot of discussion, there's a lot of hype, a lot of skepticism with the capabilities of machine learning, and no one really talks about the independent variables, because it's dynamic, it's very robust, it's proactive, but it would be really nice to see some of the end users say, what's your precision rate look like? What about recall? Where do you get your training data? And really understand all these different independent variables. And some use cases like this one, I would say, is very simple. For others, not so much. So I just thought this is something that might be helpful. Again, this is what it looks like on GitHub. This is it right here. So Wesley Raptor and then Streaming Phish. And I've got some description about this. I managed to build a decent graphic about, kind of showing how this works. You've got all these different certificate authorities. They issue these SSL certificates. They get aggregated by the Transparency Log Network. And then I've Dockerized everything in my application. So I was using Python 3, and I really like doing development on Linux. And I realized that a lot of people maybe use Python 2, or they have Windows or Mac. So I've got an automated install script for Linux workstations, Debian, Ubuntu, Fedora. But if you've got Docker and Docker Compose installed on Windows or Mac, you can get this up and running in under 5 minutes. Again, here's a little bit more about what each container, there are 3 different containers, one for the notebook, one for the command line utility, and one for the database where I'm storing. If you train multiple classifiers, you have to keep consistent the features that you were extracting at training. So I store everything in this database, and you can swap and do all of that. And again, I've got quite a bit of documentation on how to do this. So to install on Linux, I would just click this, and this says use the install Streaming Phish script. Here's what it looks like for Windows and Mac. I didn't add any automated install for Docker and Docker Compose, but if you have that, the websites have documentation on that. All you do is check out this directory, or this project, navigate into the directory, and then bring it up, and then that's that. So that's everything I had. I hope you liked it. If you think I'm a genius, if you think I'm an idiot, I'll be around for a little bit after the talk. And thanks again for staying to the end of the day. So thank you very much.